we are going to discuss a sequence which is defined recursively by this rule. Okay, so it's always a good idea first to write a few terms of the sequence out. All right, so let's do that. We have a1 as 2, and what is a2? According to this definition, a2 will be 1/2 4 plus a1, right? The previous term, that will be just a second here, just put a 2 here. Okay, and there you go, a2 is 3, and then let's write a3. Okay, so I'm going to write a3 out. So a3 will be 1/2, and according to the same rule, it will be the previous term plus 4, 1/2 of a2 plus 4, which is 3 plus 4, so you got 7/2. Let me change it to decimal because that will be a little convenient to write. Now a4 is again 1/2, and then what we shall have? We shall have 3.5 plus 4. Okay, all right, so that's 3.75. All right, so we went from 2 to 3, 3 to 3.5, and then we are then we are to 3.75, and then a5 is what? That will be 1/2 of a4 plus 4, so we will change it to 3.75. So we got 3.875, and we can see the nature of this series. I mean, started increasing pretty fast, and it's still increasing, but not, that fast anymore. Now, I think this was, this was a good work to do it by hand and to get a feel of it. And after this, what I generally advise is this, that go to the table feature of your calculator, or a better option will be a spreadsheet, and write the sequence down in the spreadsheet. In the spreadsheet, it will describe the long-term nature of the sequence much better. Okay. Now, if we wanted, we can just put these values in a spreadsheet like this, that we have 1, 2, and then we will fill in quite a few numbers, and then here, remember, the first value is 2, and then we have 1/2 times the previous term plus how much we had? We had a 4. Okay, so we got 3. Now, in order to fill the rest, you can do one of the two things. Either just copy this step and then go ahead and fill it out in the rest. All right, or you can do this, that just drag the cursor to the lower right corner of the cell. You shall see this plus sign, and then just double click on it with the left mouse, and everything will come up for you. So looks like this sequence gets closer and closer to 4. Okay, so here is the pattern that we are watching, and you can very easily go to the go to more steps if you wanted. So here I'm going to insert. I'm sorry, I just didn't highlight that in the previous one. So you can see, looks like this sequence is converging to 4. That is, as n gets larger and larger and larger, the values of the sequence get closer and closer and closer to the value 4. And even though it looks like it's showing 4 exact, now we want to mathematically prove the fact that this sequence converges to 4. So we can see, if we went by the analytical definition that we had, I don't think that we will have a very easy time. And so why don't we do this? We look at the bunch of theorems that we have seen, and notice this sequence, it is a sequence that's bounded above, right? We saw that looks like it always stays under 4. Okay, so we might think of applying this theorem that we had, that if a sequence is bounded above and is monotonically increasing, then the sequence is a convergent sequence. So notice this. Well, this quantity is less than 4. This quantity is less than 4. So far it appears that it's bounded above, but how to be sure? Now, in order to be sure, we can use the principle of mathematical induction, which says that if a statement is true for k equals 1 and assuming it true, because k equals 1, the statement is what? I'm sorry, the statement is that every term of this sequence is less than 4. Okay, so I know a1 is less than 4, ca2 is less than 4, but if we want to prove it, then first we notice this, that well, it's true for k equals 1, and we are going to let k range over the set of natural numbers. Now we are going to assume it true for just any value of k, or let me rephrase it, say it's true for n equals 1. All right, and I'm assuming it for n equals k, and again we are letting k range over the set of natural numbers. So assuming it true for n equals k means what? That I'm assuming that ak is less than 4. Okay, now what we have to do is that now we have to check for the validity of, or sorry, the verification of this statement, or validity was okay, for ak plus 1. Okay, so we assumed it true for n equals k, and we are checking it for n equals k plus 1. And what does the principle of mathematical induction tell you? That tells you that if it's true for k plus 1, then it is going to be true for all the values of n, where n is ranging over the set of natural numbers. Okay, so let's try to look at it for n equals k plus 1. Now notice this, we just assume that ak is less than 4, so we know that if we replaced this quantity by 4, okay, I think this number is 4, isn't it? You're right, this number is 4, I'm sorry. Okay, so here, so this is 4, and we have a 4 here, and 4 plus 4 over 2 will be 4. So yeah, that was a good news. Okay, or I mean easy to verify. We already had a feeling of it. Okay, so ak plus 1 is also less than 4. Okay, so what happens is this statement a, we have a sub n, okay, less than or rather this a sub 1 is less than 4, and if I assume that ak is less than 4, then this statement, it implies what? It implies that ak plus 1 is also less than 4. So by the, some people call it the first principle of mathematical induction. Okay, so by the principle of mathematical induction, what we have, that we can say that an is less than 4 for all natural numbers n for all positive integer values of n. Okay, so we found one part conclusively, that an is going to be less than 4 for every term. Now we would like to show that the sequence is also monotonically increasing. All right, that is, we would like to check that an plus 1 is greater than an for all n. Okay, or in other words, we would like to show that an plus 1 minus an is greater than 0 for all n. Okay, so let's try to do that. Okay, so we will look at an plus 1 minus an. So how much, what is the value? I know if we want to simplify it, or we know if we would like to simplify it, we get an plus 1 as 1/2 an plus 4, which you can simplify this quantity to just do some simplification of terms in or expressions in algebra. So this becomes equal to this quantity. All right, or we have these two as equals. Okay, so now let's look at this part, which is the variable part in this portion here. So I know, what do I know? I know 0 is less than an, and that is less than 4. Now 2 is a positive quantity, so if we divide the entire inequality by 2, what do I get? 1/2 an, and that's less than who? That's less than 2, right? So this quantity is positive and is less than 2. So 2 minus a quantity less than 2 is going to be what? A positive quantity. You may do it in a much better way than this, but doing too many things at one time, I mean, I thought I was able to explain it to you. Otherwise, just let me know. Okay, so what you have is that you got an plus 1 is greater than an, and that shows us what? That shows us that an is an increasing sequence, and we know that the sequence an is bounded. Let's be a little conservative on terminology. All right, so it is bounded. All right, so therefore an converges. All right, okay, so we know now that the series is a convergent series. Okay, oh sorry, the sequence is a convergent sequence, forgive me for that. And now we have to see what the limit of this sequence is. Okay, now in this case it actually converges to its least upper bound, and now that we have so many deductively proven tools at our disposal, we can even determine what the least upper bound in here is by using these methods. So what we want to know now, we would like to know that if this sequence converges to L, okay, then we would like to know who is L, or what is the least upper bound of this sequence. Okay, so now in order to do this, well, let's recall our previous the relationship that we had, okay, for this one before. Now using the algebra of limit of sequence, we know this, that we got n going to infinity, so we will apply the limits, and this is a simple equation, so we can safely do what we are doing, even though we should always be a little cautious while writing such things. Okay, so this limit has to be L. All right, okay, then 1/2. Then what we got? We got L plus 4. Now we have an equation in L, and you can solve it. All right, I'll let you solve it at your own leisure. Okay, so L is 4, or in other words, this sequence converges to which limit? 4. Okay.